So evolution of a electronics. So how the evolution of the electronics is happened by day, how it is being evolved year by year, we can say. Okay, so first we will learn the introduction. What is an electronics? Okay, so the word electronics is actually been originated from the word electron. Okay, so based on the electron flow, we are defining all our electronic equipments. Okay, so it's mainly depend upon the flow of the electrons. Okay, so electronics is a branch of science dealing with theory and the use of devices in which electrons travel through vacuum gas or a semiconductor medium. Okay, so how the electrons are being traveled through the vacuum gas or a semiconductor medium. So the complete electronics is based on this concept. Okay, so these are the different mediums in which the electrons are traveling. Okay, so we have considered it as vacuum gas or a semiconductor medium. Okay, so the electronics is a field of science, you can say, which deals with the motion of electrons under the influence of applied electric or a magnetic field. So if any semiconductor medium we are considering, and so I'm just writing here, suppose we have considered a diode. Okay, so it is a diode. So how the electron will flow through this diode, we have to apply external supply. So here we will be considering it is a positive supply. Okay, so or a battery, DC battery we are considering here. So based on this external electric or a magnetic field, which we are going to apply across the electronic equipments, based on that the flow of the electron is dependent. Okay, so therefore electronics has been evolved around these components. Basically, which components are there? Sorry, three components. So first component we are considering, it is a vacuum tube, then transistor. Okay, vacuum tube, transistor, and the integrator circuits. So we are going to learn about how the vacuum tube is being designed, how it is being evolved for the further processes, how transistor is being designed or invented. So all this concept we are going to learn here. So yes, so the next part is the pre-electronics era, how it was basically, or we can say before 19s. Okay, so discovery of electricity. Electricity is by Benjamin Franklin in 1752 with light experiment. Okay, and Alessandro Volta in 1800s invented the voltaic pile, or we can say it is an electric battery. So the first electric battery was invented by Alessandro Volta in 1800. Okay, and Michel Faraday, who has invented the electromagnetic induction. So for the electric motor and the generators, it is being used. The concept of the electromagnetic induction. So we will first learn about the vacuum tube, how it is being developed or the invented. Okay, so the vacuum tube era is mainly from 1904 to 1950s. Okay, so in 1904, Sir John Ambrose Flemings invented the vacuum tube. Okay, and in 1906, Lee De Forest invented the triode. So enhanced version of the vacuum tube, we can say it is a triode, which is being invented by Lee De Forest. Okay, in 1906, and their application is simply radios, television, and the radars. In the earlier stages, these equipments were used, means vacuum tube or a triode, we can say it is being used in the radios and the televisions. Okay, and the radar. So this is the first vacuum tube, how it is being looks like. Okay, so it is quietly in a big size. So we'll see the first electronic computer by considering all these equipments, how it was the size of the first computer, basically how much in meters or in a cubic area. Okay, so the first electronic computer was invented in 1945 and it was ENIAC. Okay, so the physical size of this computer was about 30 meter in long, 2.4 meter in height, okay, or a height we can say. So roughly the size of a large room. So if you can analyze that, how the first big computer was, okay, then their weight was 27 tons, and the total components were used there was approximately 18,000 vacuum tubes. Okay, so these vacuum tubes were we used nearly 18,000. Okay, 70,000 register was used, 10,000 capacitors was used, and the 1500 relays. Okay, relays are simply being used for the switching purpose. Okay, so we can say is a mechanical switch, and the total power consumption was about 150 kilowatt. Okay, so huge power consumption was there. So the limitations where it is a bulky, fragile, consumed high power, and it also generates the heat. Okay, so these was the limitations of the vacuum tube. Okay, so we'll see the structure of the vacuum tube, how it was basically. Okay, yes. So vacuum tube, I will just erase what I have drawn here. Okay, yeah. So the vacuum tube is mainly we can say the combination of anode, cathode. Okay, so here if you see there is anode. Okay, anode is being here. So the cylindrical shape is for the anode, nearly for the grid. We can say for the cathode, heated cathode is in a cylindrical form. Okay, so this is nothing but a anode. Okay, then around the heater, the yellow one which is shown here, it is a heater. Okay, around the heater there is a cylindrical shape which is in the orange color. It is nothing but a cathode. Okay, heated cathode we can say. And apart from that, around the cathode there is a one grid is being connected. So how it functions basically, so if you see here, we'll see the comparison or the explanation for the vacuum tube. First, we will consider the diagrammatic form of the vacuum tube. So this is the actual vacuum tube structure. Okay, so here we are considering the anode. Okay, anode. Here it is a cathode, and the here inside between the anode and the cathode, we have shown it is the flow of an electron. Okay, from here to here, it is a flow of an electron. Here it is a heater. So this is a heater. Okay, and the applied voltage source. This is the applied voltage source. So the positive terminal is connected to the anode and the negative terminal is connected to the cathode. So how it functions basically. So here the heater will generate the heat, and the cathode will be means that heat is being transferred to the cathode, and cathode will just emit the electrons, because on the cathode there is one material is being coated with. Okay, so that material we are calling it is a metal cylinder, or we can say coated with the material emits electron. Okay, so there is some coating there on the cathode. So due to that coating, once the cathode is being heated, okay, so here is a cathode which is being heated. So through that coating, electron emission is being happen. So the electrons emitted from the cathode, okay, started. Okay, and it will move towards the anode, because electron always uh, attracted towards the positive terminal. Okay, so here the cathode is being connected, here the cathode is being connected to the negative terminal. Okay, so here it is a negative terminal, and this anode is connected to the positive terminal. So this electron which are flowing from cathode to anode, okay, so these are the electrons will attract towards the positive terminal. So this is the flow of the electron. Okay, so it will attract towards the anode. So likewise, the flow of an electron happen inside the vacuum tube. If you see here, we have shown the two directions of the current. First, we have considered it as a current, or we can say it is a conventional current. Okay, it is a conventional current, and one is the electron flow to the supply. So just remember that the difference between the conventional current and the electron flow of the current is simply electron flow is from the we can say from the negative terminal to the positive terminal always. Okay, and the conventional flow we are considering is from the positive terminal to the negative terminal. So why it is so? Because before invention of the electrons, so the scientists were considering that the current were flowing from the positive terminal to the negative terminal. Okay, but once the invention of the electron happened, so it is understood that electrons are actually flowing from the negative terminal to the positive terminal. But during solving the problems, if you are considering the conventional current flow or the electron flow, we are not having any difference in the output. Okay, so it is decided that the conventional current will also being considered and the electron flow also being considered. So many of the times for solving the problems or the circuits, the conventional current is being considered. Okay, so this is the basic difference between the electron flow and the conventional current. Okay, so the direction of the conventional current. So this is the structure and the operation of the vacuum tube. Now we'll move further for understanding the triode function. Okay, so here we have seen that vacuum tube is mainly having the two terminals. One is the anode and another one is a cathode. Okay, two terminals are being there in the vacuum tube. But in the triode, there is another one terminal is being introduced, and we are calling it is a grid. Okay, so we'll see the function of the grid for what purpose it is being introduced inside the triode. Okay, so first, who has invented the triode? It is by Lee D. Forest invented the triode. Okay, and it is mainly being used as an amplifier. So the main function of the triode is amplify the signal, is to amplify the signal. So we'll see the structure first. Okay, so triode is having the three terminals. Okay, here is the anode. So this terminal is the anode, and this terminal is a cathode. Here it is a heater, the same structure as per the as like a vacuum tube. And another terminal is being added here, which is nothing but the control grid. Okay, so cathode, anode, and the control grid, it is three terminals are there in the triode. Okay, so cathode emits the electron, which we have seen inside the vacuum tube. The functionality of the vacuum tube for generating the electrons or the emission of the electrons is same in the triode also. Okay, so here cathode emits the electron when heated. Okay, so we are calling this thermionic emission, and anode plate attracts the electron, which is positive voltage applied, means we are applying the positive voltage to the anode. If you have seen here, the anode is connected here is the anode is connected to the positive supply, and this cathode is connected to the negative supply. Okay, so same in the triode too, we are connecting a anode to the positive supply and cathode to the negative supply. So what is the function of the grid here is, see here, the another terminal grid which is being denoted by G, placed between the cathode and the anode, which controls the flow of an electron. We know that electron is having the negative charge. Okay, electron, suppose the electrons which are generating at the cathode, which is having the negative charge. Okay, so the negative charge will always attract towards the positive. Okay, so suppose we'll see point by point the explanation of the grid, how it is. So yeah, so first the cathode is heated. Once the cathode is heated, electrons are being released, okay, from the cathode terminal. A positive anode attracts this electron. Okay, so this anode will attracts the electron from here. Okay, then The control grid voltage small negative bias regulates this flow. Means see here, suppose we are considering the grid is a negative supply. Means here we have connected the negative supply to it, so this terminal will be negative. Okay, so what will happen if it is a more negative? So the negative terminal will repel the electron which are coming from the cathode. Okay, it will repel, means it will repel towards the anode. Means the speed of an electron will increase once the control grid is being negative. So once the control grid is more negative, so more repel of the electron is being happened. Okay, so likewise the we can say the current is being increased. So initially the current was smaller. Okay, so suppose we are considering is zero point 0.2 milliampere, so it is being increased to suppose 0.25 milliampere. Okay, likewise. So yes, so if we are considering it is a positive one, so what will happen? If the control grid terminal is positive, so in that case this electron will attract towards the control grid. So speed of the electron towards the anode will decrease. So we can say the um, current will decrease. Likewise, so the control grid here works for uh, increasing or decreasing the current which we are generated at the cathode. Okay, which generated at the cathode. So this is the function of the triode. Yes. Okay, so the function is being done for the triode. Now we'll move towards the transistor. Okay, so the transistor era was between the 1947 to 1960. Okay, so we can say here from 1947 to 1960 there was a transistor era. So who was invented the transistor is by John Bardeen, William Shockley, and Walter Brattain. Okay, so these three scientists were invented the transistor. Main thing in the evolution of the electronics, the scientists and the team were mainly decided to reduce the size of the components. Okay, so initially the vacuum tube was big in size. Then for the control purpose, one terminal is being added, but the size is the same for the triode. Okay, now for the transistor, so for the transistor we can say, right? Yes. So for the transistor, size is being decreased compared to the vacuum tube or a triode. Okay. So the advantage is it is small in size, reliable, low power is being required for that, and the long life. Okay. So life of the transistor is also being increased. And their application is portable radios, in telecommunication, in hearing aids, beginning of the miniaturization in electronics. Okay. So miniaturization is simply is nothing but reducing the size of the components. Okay, so this is the concept of the miniaturization. So actually when the transistor is being developed at that time, the actual beginning of the miniaturization of the electronics happened. Okay, so this is basically the greatest invention of the 20th century. Okay, and there is a two types mainly, NPN and the PNP transistor. Okay, we are going to learn in detail in the BJT or the transistor unit. Okay, so there are two types mainly, NPN and the PNP transistor. For this transistor, the middle region we are always considering it as a base, middle one as a base, and it is very thin and lightly doped, we can say. And the two terminals we are considering it is a emitter, okay, emitter and the collector. These are the three terminals of the transistor. Okay, so yes, so what is the working of this is a small current injected into the base emitter junction controls a large current which is flowing between the collector and the emitter. Okay, So here the base is being introduced is mainly for controlling the current. Okay, so the base emitter current controls, or the junction controls, the large current flowing between the collector and the emitter. So maximum current is trying to flow from the emitter terminal to the collector terminal due to the base region introduced, which is being introduced, which is lightly doped, or it is a very thin. Okay, and it is a lightly doped. So the base current, we are saying it is IB. So we can write it like this: IB controls the collector current, which is IC. Okay. So modes of operation are mainly cutoff, active, and the saturation. So these are three operations or mode of operations being considered for the transistor. So in cutoff region, it acts as a switch. It acts as a switch, and in active region, it acts as an amplifier. Okay, for the amplification purpose, the transistor is being used in the active region, and to works as a switch on, it is being you working in the saturation operation or a mode. Okay, so means maximum current is being passed in the saturation region. So these are the three operative modes of the transistor. Now the integrator circuits. Yes, once the transistor is being developed, so the integrator circuit, next part is the integrator circuit. Okay, so simply how the scientists were decided that how the size of the equipments can be minimized. Okay, so day by day the size of the semiconductor equipments are being reduced. Okay, so the integrated circuit was invented in between 1958 to 1970s, and in 1958 Jack Kilby, okay, and the Robert Noyce independently invented the integrated circuit. Okay, and the integrated circuit is mainly the combinations of many transistors, resistors, and the capacitors. Okay, on a single silicon chip. So this is the main advantage of the integrated circuit. So it is being kept on different components kept on the single chip. So it is enabled or used in the calculators, watches, consumer electronics. Okay. First, we can say Apollo 90's guidance computer, 11's guidance computer was moon landing in 1969, in where the IC concept was being used. Okay. So how it is being evolved now, we'll see. So the first transistor after the invention by the three scientists, first transistor on a flat, we can say flat surface, is being designed in 1950s. Okay, a single silicon transistor, or a one transistor we can say. And in 1960s, first TTL quad gate is being designed, which were having 16 transistors on a single chip. It is also the combination of different resistors and the capacitors on that, but we are taking the count of the transistors only here. Okay, so in 1960s, TTL quad gate is being designed with 16 transistors. Okay, and in 1970s, first 8-bit microprocessor is being developed, which were having the combinations of 4500 transistors. Okay, and in 1980s, there is a 32-bit microprocessor is being developed, which were having nearly 275 transistors on a single platform. Okay, yeah, you can analyze that how it is being evolved and how the size of the components, the chips are being decreased day by day. Okay, so the main concept is being used here is VLSI, very large scale integration. Okay, then in 1990s, 32-bit microprocessor is being designed with nearly 31 lakh of transistors on a single chip. And afterwards in 2000s era till present, okay, so 64-bit microprocessor is there, and it is nearly 59 crore 20 lakhs of transistors are there. Okay, or we can say it is 0.592 billion transistors are there on the single chip. Okay, so yeah, I will see some advantages of that. how it is being evolved. So the microprocessor and the personal computer era was 1970 to 1990s. Okay, so in 1971, first Intel 4004, first processor was being developed by the Intel, which is being a complete CPU on a single chip. It provides the rapid growth, and afterwards the IBM and the Apple also develop some operating systems. So MS-DOS and the Windows. And for the digital communication, gaming console, it is easy. Then electronics become accessible to everyone in the era of 1970s to 1990s. Okay. Then in modern semiconductor era, from 2000s to present. Okay, so we have discussed just like a very large scale integration. So by using this concept, very large scale integration, billions of transistors on a single chip, okay, is being introduced, or currently it is being using, or for the integration purpose, this methodology is being used. Okay, so in a smartphone, Apple iPhone, we can say, in 2007, phone plus camera plus computer is on the single chip. Then for the Internet of Things means simply we can consider all the equipments are being connected to the internet. Okay, so currently smart homes are there. So from the homes, all the equipments are being connected to the internet, so we can access it through the internet, all the equipments. Then wearables, just like a smart watches. Okay, then fitness band. Okay, then the automation, then nanotechnology and the semiconductors. So high performance processors are being developed. Then GPUs, graphics processing units, are being developed. Then currently AI and machine learning is in a boom, or currently there is a current trend is going on based on the AI and machine learning. Okay, uh, you can say the edge computing and the robotics also taking the benefits of the AI and machine learning. Then in healthcare also it is being evolved, in defense, space, entertainment, finance, and the education. Okay. So this is basically the evolution of the electronics.